let us see why do you want to do analysis. Now, if you see, these structures are built without much knowledge of what stress is, what strain is, or what cause relationship is. The pyramids date back to 100 BC or something like that. The Brihadishwara temple or the big temple in Tanjavur is around 1000 years old. The Leaning Tower of Pisa is also around 1000 years old. In contrast to this, what is the difference that you see in this structure? The difference is the sleekness of the structure compared to the massiveness of these structures. Now, this is where the current science helps us. Basically, the resources you have is limited and you want to use those resources effectively, meaning you do not want to waste resources. You do not want to build a structure to last for 10,000 years when the intended design life is just 50 years or 100 years. Similarly, you do not want a structure to fail in 20 years when you intended to last for thousands of years. Okay. So, that is the intent. You want to use resources economically. When you say you want to use resources economically, you should have an understanding of how the structure responds to a given scenario or when the structure will fail. Now, when I say failure, what do I mean by failure? Is concrete crushing a failure? Is steel yielding a failure? Is a garbage bag just deforming too much under the weight of the garbage load? Is it a failure? That is the question I am asking. In other words, is this the failure of the body, or is this yielding which has occurred and buckling that has occurred the failure of the body? What is failure? We have to understand this before we proceed. Failure by definition is if the structure does not fulfill its intended use, then it is said to have been failed. I will give you some examples. In the buildings, you have a reinforced concrete beam which would have failed, which would have cracked due to the dead load. That is not a failure of the beam. The same reinforced concrete beam, if it were to be part of a water tank, the cracking of the beam is detrimental because water will seep in through the cracks, deteriorate the concrete, and it might also cause leakage of water stored in the tank. So, what is not a failure in one case can mean failure in a different scenario. Okay. So, the reinforced concrete beam which has cracked because of tension in the bottom is not considered as failed in a regular residential buildings. Okay. The same reinforced concrete beam in the same residential building, part of a water tank, is considered to have failed if it cracks because water might seep in through the cracks. Okay. Similarly, the yielding of a structure under earthquake scenarios is admissible provided the structure does not collapse due to this yielding of the steel members or yielding of its components. On the other hand, if the steel member were to yield under a normal live load situation, normal loading situation, then it is considered to have been failed. In both these examples, it is a load that causes cracking or the failure of the body. There are other instances wherein it need not crack, it need not yield, but still the structure would have been deemed as failed because it has not served its intended use. Examples of these are these mobile antenna towers, this weather antenna towers, and so on, wherein it is essential to maintain the deformed shape, or it is essential to maintain the shape of the structures accurately, because the mobile tower will not be able to receive signals if it deforms more under a wind load or under heavy rains and so on. Similarly, this weather antenna would ask to maintain its parabolic shape under extreme wind loads If it does not, it is deemed to have been failed, because it is used to track the cyclones and things like that, and you do not track cyclones when there is quiescent conditions. Okay. So, basically failure means different things under different scenarios. There can be failure because the strength or the stresses exceed a limit, or it can be displacement cause failure when displacement exceeds a limit. Another example of displacement induced failure is, say you are walking on this floor, and if the floor sinks by a meter, do you feel comfortable walking on the floor? No, right. So, that is an example of a displacement criteria governing the design. Okay. So, in essence, there are two reasons why you want to do analysis. The first reason is to ascertain the safety of the structure under given conditions. Okay. When I say safety of the structure, it means I do not want the structure to fail. When I mean safety of the structure, I do not want the structure to fail. So, there are two criteria here. One is strength and the other one is displacement. That is, I want to find and ensure that the stresses in the body does not exceed a particular limit for the given loading conditions. Similarly, in displacement, I want to compute the displacement on the boundary of the body or in the interior of the body where it is not specified, and I want to ensure that the displacement is within limits. Okay. So, strength means I want to compute the stresses in the body and ensure that these stresses are within the limits. Similarly, displacement means I want to ensure that the displacements of the body is within the permissible limits. So, that is what I want to ascertain first for a given structure. That is why I do analysis. Okay. The second reason why I want to do analysis is to find the support reactions. I want to find the support reactions, and hence I want to do an analysis. Now, let us understand why this is important. Okay. Now, say I have a column, this is a column, it has some load P coming on it, it is resting on some foundation which is resting on some ground. Okay. This is a ground on which it rests. Now, what do I assume? This column is, say, part of a portal frame. There is some load acting here P. Now, the question is, what is the end conditions I would assume for this column? The end conditions can be a hinge condition, or it can be for the same portal frame, it can be a fixed condition. I am sure you would know what this hinge and fixed means. Hinge means it will not resist any moment, this does not resist, the symbol means it does not resist any moment, it is free to rotate, On the other hand, this symbol means it is a fixed beam, which means it will resist rotation and generate moment. at this support. Of course, this being also this will resist, both will resist the displacement in x and y direction, or in any direction the displacement is restrained. Okay. Similarly, this support, this fixed support also will resist, this will also resist displacement in any direction. Okay. So, that is the meaning of these supports. Now, what is that I have to assume? That depends upon how I have designed the foundation. There are two options. One is the foundation can rest on the earth like this, or the same foundation can be resisted by piles like this. Okay. That these are called as piles which go down beneath the ground, and there is these two possibility of foundations. Now, which foundation will be idealized as a hinge foundation, and which one will be idealized as a fixed foundation? That is the question. That depends upon how the foundation has been designed. Now, when I say how the foundation has been designed, I have to say what are the supporting forces, moments that the foundation has to resist. In this case, I gave only an axial load. In this case, I can have an axial force and a moment coming in on the column. Okay. So, because these files will resist, this file can take tension or compression, and it can resist. Basically, when it tries to rotate like this, when this tries to rotate like this, this has to go up and this has to be compressed, which will be resisted by the frictional force here. The frictional force will offer the resistance, and here the bearing force will offer the resistance. Okay. So, basically now there is a mechanism for this kind of a foundation, to resist the applied forces, and hence for this the appropriate idealization would be this one. Okay. On the other hand, here if I have a moment, this one is free to rotate and it will rotate like this. There is nothing that prevents this from lifting up. There is something preventing it from going down, but that will cause failure of the foundation rather than preventing it from uplift. Okay. So, when there is a moment that is coming in here, this is what will happen. Here it does not resist the moment. So, the appropriate idealization for this scenario is hinged boundary condition. Okay. So, now what we understand from this is how you view the boundary condition is important. What is the boundary condition that you have to assume for the structure depends upon what you have designed the support for. Okay. And real life example of where this foundation went wrong is the Leaning Tower of Pisa. The Leaning Tower of Pisa. What happened here was the foundation was not designed properly, and hence it sunk on one side more than the other side, causing it to have a tilt. Okay. So, that is why it is essential to understand what you are designing the supporting structure for and have a suitable idealization in your analysis. Okay. So, it is for these two reasons that you do analysis. One is to ascertain the safety of the structure and to find the support reaction, so that the supporting structure can be suitably designed. Okay. Now, we saw till now what a deformable body is. Why do you want to analyze a body as a deformable body? We saw what are the concepts in mechanics and the 4 equations that connect those concepts. And why do you want to do all this analysis? People have been building buildings, structures from time immemorial, but the reason why we want to do is to have a rational basis for utilization of resources. Okay. Now next let me conclude this part of the lecture with what are the objective of these courses and what is the knowledge that I expect you to have coming into this course. I told what is that, in other words you will understand what is that you are gaining from this course, what is that you have to come as with an input in this course. So the objectives first, objectives of this course is 4. One is to be, at the end of this course you have to be able to relate the stress components to the force components. You know that force is a vector, it has 3 components. Similarly, stress has 6 components. You have to be able to relate which component of force acting in which area corresponds to which component of the stress. Okay. So, we will see more of those in the coming lectures. Second objective is to be able to relate the strain components to the displacement components. Okay. The third objective of this course is to be able to solve one dimensional problems of engineering interest, like axial members, beams, pressure vessels, torsion, okay, torsion members. Okay. The fourth objective is to be able to predict the failure load and mode of failure. That is, whether the concrete is going to fail by crushing or is the geometry of the body causing it to deform more, which is resulting in the failure. That is, material failure versus the stability induced failures is what you are going to see. Even in material failures there can be yielding, there can be crushing, there can be cracking. So, which of these failure modes the body is going to fail is what you have to be able to predict, and what is the load at which this will fail, a given body will fail, that is beam, at what transverse loading the beam would fail, or at what torsional moment the member would crack. These are the things that we have to be able to predict at the end of this course. Okay. So, these are the objectives of these courses. Now, let us understand what knowledge or what is the skill set that you have to do well in this course. Skill set required. One is should be knowledgeable in calculus, differentiation, and integration. Then differential equations. This is an absolute prerequisite for this course. Having a knowledge on calculus is an absolute prerequisite of this course. If you have knowledge on linear algebra, that would be a plus. Basically here you should know how to matrix multiplication, or in general matrix operations. Okay, you should know matrix operations and then some amount of vector algebra, that is how do you add two vectors, or what is the scalar product, what is the cross product, what is the scalar triple product. If you have knowledge on those, it is a plus, but I will be covering most of the linear algebra that is required for this course. It will be a self contained lectures on linear algebra. Okay. But calculus is something that you should know. I am not going to teach you how to integrate, differentiate and how to formulate differential equations, or how do you solve differential equations, something I am not going to teach you. Okay. But having a knowledge of calculus and linear algebra would help you do well in this course. Okay. So, we have seen the objectives, the skill set that is required, and then some basic concepts that we will be learning in this course, and why do you want to do analysis. Okay. So, with this I conclude this part of the lecture. In the coming lecture we will start off with the first concept in mechanics, which is force. Okay. Thank you.